Hi, everyone. Welcome to Timeplus's February 27th, 2025 webinar. My name is Sarwar Bhuiyan. I'm Field CTO here at Timeplus, and I'm joined today by Chen, our Chief Architect at Timeplus. I'm very pleased to also welcome Ibrahim Bakhsh, a Senior Cloud Data Manager at one of our customers, Salla, to speak about the usage of Timeplus and the impact it has had on their data pipeline implementations. We'll start off with the customer story, where Ibrahim will walk us through how they decided to use Timeplus with their architecture. Ken will walk us through what is in the current release 2.7, and we will also take a sneak peek on what is coming in 2.8 and in our open source Proton project. We'll take some questions at the end. So before I hand over to Ibrahim, I just wanted to give a brief introduction to Timeplus. Timeplus is a unified streaming SQL platform. It's quite opinionated in solving stateful and stateless stream processing. It supports historical data processing as well. It's used in many different use cases, such as real-time applications for data pipelines, for ad hoc queries, metrics, and alerting. It's used across the industry in different domains, from FinServe to gaming, e-commerce, which Ibrahim is going to talk about. We've had users in IoT, fleet management, and oil drilling as well. Ibrahim, welcome. If you want to take it away, this is about how Salla came to build up a big data pipeline and how they came to get introduced to Timeplus. I want to first just request Ibrahim to say a little bit about himself and his role and how he progressed.
Thank you, Sarwar. I started as a DBA for work more than 15 years in this field, and then I migrated to working as a database architecture, working with cloud solutions and with big data gave me the ability to see multiple problems and try to find various solutions to the problems. At the beginning, we faced a lot of issues processing a massive amount of data every second and in a small window. Using ClickHouse at the beginning, we found that there are multiple limitations, and ClickHouse wasn't built for strategically for our use cases, for all of our use cases. So we started looking for another solution, one of which was Timeplus. At the beginning, we were unable to determine how exactly it will fit into our goal, but after a few meetings with the team, everything became clear, and we started going and tackling every challenge by challenge, every problem that we faced. And we found out that Timeplus actually can help us reduce a lot of duplication in code and a lot of duplicate streaming that we are doing and processing. We started by CDC problem. We have a massive amount of CDC pipelines going from multiple databases and schemas into analytical databases to have some aggregation between AI team and other teams for many different purposes. Using Timeplus, we decreased the number of overhead 3 times into CPU and hardware requirement. With less hardware requirement, we were able to deliver much faster CDC approach. And then after the CDC challenge, we went and tackled another problem, which is multi-join. We're starting by having a different duplicate processing for every stream that we had in ClickHouse. So like we know in ClickHouse, when we start listening to any stream to try to process any data and make it available on a stream level based on the rows or based on the Kafka stream that is coming, we can only have a single stream at a time. So in case if our data coming from multiple sources or multiple tables, we had to duplicate our processing again and again and again, sometimes up to 5 times. With Timeplus, we were able to have a single processing pipeline that can combine the power of remote lookups with recently with the MySQL joins and direct joins on a stream basis. And that actually gave us an advantage into having a single source of truth into our data, into our latest data. And Also, with the processing time, the delivery of our data in a peak time and in various load changes, they are time plus actually scales out and scales in quite in a very good way. It scales out our threads and keeps the overhead of opening multiple threads in ClickHouse for every stream and reaching the maximum number of threads. Time Plus has discovered from the grounds up. I believe that Ken will actually introduce some of the metrics and some of the wins that we had in that department. On the other hand, with remote lookups, they did something amazing using hybrid hash joins, which is something like caching the data that's being retrieved into lookups. So we don't have to go and visit the remote lookup database or tables again and again and again for the rows that have been already used frequently or recently. So any frequent data that we are putting, we had it already in time plus cached in a way that speeds up our performance and actually gives us a stable system that we can rely on and scale out very easily.
Yeah. Do you want to talk about the other, streaming and alerting to other systems as well?
We are using Time Plus actually to sync back to multiple destinations at the end. Having a single, there is a challenge that we had in ClickHouse where we have a single source of truth or multiple truths, and then we had to write our own code again and again to duplicate or send that data to multiple systems. Time Plus recently joined an effort with Red Band Connect, I think. And with that effort, they gave us the ability to sync back our data into more than 200 connectors. So that was a big win for us also in the syncing part. So we don't have to rely on our own code again and again and write our own apps for processing all the data that needs to be delivered and reducing the number of queues and reducing the overhead for hardware and the cost. In many aspects, it was a single solution that can serve us in data processing layer, and it was great.
Sure. Thank you. So I want to leave some time for Ken to go over a little bit more of a deep dive into the features that helped do all this.
Thank you, Ibrahim and Sarwar. Yeah, so in 2002, we have a general release, which we provide the hybrid hash table and other enhancement. Hybrid hash table will be in this release, play a very important role in this release as well. So in 2007, we have a bunch of very, very cool features and then also enhancements like dictionary. It will play a very critical role in Salla's use cases as well. And we have the direct join and MySQL external table, S3 external table. We have a bunch of other enhancements in Timeplus console and also Timeplus Connect. We will cover some of them in detail in the next few slides. In 2008, we are scheduling another release in March, and we will have even more exciting updates like elastic material view auto scaling. So user can run hundreds, tens of thousands of material view. Compared to today, we have thousands of materials right now, and the cost efficiency will bring down a lot. And we also have the Apache Iceberg integration, Postgres integration, S3 tier storage. Most importantly, we have a new JSON data type, which can have way more better performance regarding the JSON document processing and also multiple stream updates. Yeah, time plus dictionary. Dictionary, basically, we introduced dictionary. Basically, the problem we're trying to resolve is, so assuming you have a lot of data in your remote MySQL database table or Postgres database table, you just do not want to move the data around into time plus, for example. That's too much data, like billions of data, billions rows of data. And just like I like to do remote lookup the remote MySQL database table directly. And also, the second problem is that users do not want to introduce many different hash table. For example, when we do a join, for each of the query, you have many queries, and each of the query will share the same cache. Instead of each of the query will basically build its own hash table. That will save a lot of memory and the resources. So dictionary essentially is a shared proxy, and can be cached to a remote table or local stream for fast lookup. And dictionary can be used in a like a hash table lookup, like a dictionary get in a SQL projection. And it can be used in a join, in a direct join, for example, for the data enrichment. In this example, we have created MySQL dictionary, and every dictionary has the primary key, and it has the source basically tells what type of remote sources. We support different remote sources, and also where we can get the data if the data is not in the cache. And we also support different layouts. Layout is just like the cache mechanism. It can be a hybrid hash table. It can be a direct pass through, and which is very versatile for the source and the layouts. Yeah, as indicated in the last slides, basically dictionary can have different layouts and also sources. Right now, we support MySQL remote source, Postgres SQL remote source, and the ClickHouse, and also Timeplus. So when we do a join, when we do a dictionary lookup, if the data is not in the cache, it can fall through to the remote sources to get the data, and using the data to populate the local cache. And the cache can be, in memory hash table, and also it can be a different data structure like a trie, which is very useful for the IP lookup. For example, if you like to IP lookup for some of the IP processing, prefix lookup, and they can be a hybrid hash table. This is very useful for high cardinality data. So, for example, we have billions of data in MySQL, Postgres. In order to cache all of the keys, it could be very memory intensive. So hybrid hash table basically can build the key onto the disk if does too many keys reach a threshold. And we can even use a mutable stream as the cache layer. That is even more powerful. Because mutable stream can support not only primary key join, they can support the secondary key lookup as well. And also, sometimes users do not like to cache the data. So because they like to always fresh data, they can directly pass through to the remote sources as well. And the layouts and the sources basically are two components that can mix and match, which is provide a very versatile solution. And the user can mix and match them together to solve their problem by considering the latency, by considering the data freshness. The direct join is a new type of join, which we introduced in this release as well to help Salla's use cases. So direct join is the powerful of direct join is like they do not need to build a hash table on the right hand side for the join. So usually when we do the join, we need to for every join for every join for every query. So for example, you have tens of joins, you have tons of join SQL statement, and each of them will need to build a right hand hash table for the join. That will cost a lot of memory overhead. And direct join is like I do not need to build the hash table again. Because the on-disk data structure, on-disk storage engine already have the primary index or secondary index. I can look up the storage directly instead of building another hash table. That is specifically useful in data enrichment use cases. In this example, we provide an example here. So the join, the left-hand side is auto stream, and the right-hand side can be a MySQL cache dictionary. The right-hand side can be joined a MySQL direct lookup, direct dictionary, which is without a cache. The right-hand side can be a Timeplus mutable stream as well. So in this diagram, actually, so for example, remote MySQL can have live updates And the multiple stream can be updated by another CDC stream, for example. And the right-hand side is always live. Instead of a snapshot, it's always live. And this provides the data join speed, provide the data join speed as well as the data freshness, which is very, very powerful. So in the meanwhile, we provide the MySQL XML table. We already support different XML stream like Kafka, Pulsar, S3, and the MySQL is the new one. And user can basically read and write from the remote MySQL and to the remote MySQL, which is very, very handy to explore the data around the system here. So Python UDF, which is another very exciting updates in this release. So previously we have the native JSON, native JavaScript script UDF, which is a very big success. So our customer is basically asking more regarding the Python integration for the machine learning and also AI use cases. So the current Python engine is basically a built-in without any kind of remoking the sub-process of the Python interpreter. In general, basically, we embedded the Python interpreter into a Timeplus binary, and user can just write the Python UDF as using a Python interpreter to run the Python scripts. So here are some of the examples. User can create a function, create a Python UDF function, and they can import the OpenAI library and also ask some of the AI questions. Next one. And another example, user can import the stars forecast machine learning library and do the forecast for some of the real-time data as an example. The Python UDA is a different type of Python, user-defined function. It's very stateful. So instead of the user-defined function, it's like a transformation for many to many. User aggregation function is different. It's basically many to one. And this is one example. User can write a very sophisticated using Timeplus Python user-defined aggregation function to do aggregation. So this example is basically calculate the maximum for the value as an example. Next one. In the meanwhile, we have quite a lot of exciting updates for the Timeplus console. So previously, we do not support the multi-database. And for example, in Salla use cases, they have lots of put different resources, different materials view, different streams in different database, and user right now can have a drop down to navigate resources in different namespaces or database, which is very handy. And in the meanwhile, the most important part in this release for the Timeplus console update is the advanced state monitoring. So if user have hundreds of materials view or even thousands of materials view running in the system, so user need to know what went wrong and what is the material view processing lagging, what is the data replication lagging, what is the checkpointing looks like. And also, what about the storage usage? What about the checkpointing storage usage? What about the material review storage usage? Lots of different metrics can be viewed in Timeplus console. It is exactly become a go-to tool for all of the Timeplus material review troubleshooting. In the meanwhile, we have the Proton OSS update as well. Proton OSS is basically a reference implementation of the Timeplus Enterprise. So in this release we have we can process the Kafka headers, Kafka message headers, and also we can rewind and replay the data according to a timestamp range, also at the speed. This is very useful. For example, users have the data already, and they like to replay the history at the exactly same speed as the event happened. And for the reproduce the issues, rerun the algorithm to see what happened. And also we have new SQL aggregation function like group cat, group concat last. So in the next release, we will provide the MSK IAM role support in Proton OSS for Kafka Extra Stream, and also we will have L3 integration, Iceberg integration. Thank you.
So now we have a few minutes for questions. So I'd like to start with one, which is around just a basic kind of recap of the difference between streaming joins as we had before versus joins with the dictionaries or the join direct algorithm. what do we gain and what do we lose?
Yeah, so this is a very good question. So the direct join is basically user to the gain is very obvious. User do not need to build another hash table. And when the right hand coordinate is really big, and also you need the live data on the right hand side. For example, on the right hand side we have the customer dimension or a different dimension, and customer the dimension table can be changed. If we build a very huge hash table on the right hand side, the coordinate can be hundreds of millions or even sometimes billions. And building this hash table is very expensive. So in Timeplus solution, we can use the hybrid hash table to mitigate that problem. But direct join provide another way, which is like you do not need even have a hybrid hash table, and you just direct join the storage engine in the storage engine in the file system, and also that save a lot of memory. Number one. Number two is basically the right-hand side can be dynamically updated by using a different stream. For example, I have another CDC stream to update the mutable stream. And when we directly look up the mutable stream, it is always the fresh data. It's always the fresh data. The cons is that absolutely building another hash table will may speed up the performance. Direct lookup may be slow, a little bit slower, but with time plus mutable streaming, for example, it provides very fast primary key lookup and also secondary key lookup. Yeah, this is where time plus solution really is there.
Okay, so we've got another question here around what does the remote join performance look like, if you can share any numbers or comparisons with, say, ClickHouse materialized views, which just does the joins based on the left-hand side events.
So we have some of the benchmark internally. So depending on the dictionary, since that we have that remote lookup dictionary, can using dictionary, can using the cache or without the cache. So if without the cache, the all of the performance bottleneck will be the light speed. For example, we need to compose the real time SQL query to remote MySQL database, for example, for that key, for a batch of keys, or a batch of keys. That back and forth is basically the performance is basically limited to the MySQL database table, remote MySQL database table. So, but even in this case, in our test cases, they can reach tens of thousands events per second join. And if we are using the local cache, if we're using the local mutable stream, for example, that will be higher, tens of thousands sometimes, yeah, event per second join speed. And regarding the ClickHouse comparison, ClickHouse is a very different solution. So basically, they need to compose for every event on the left-hand side. They need to compose a full SQL. Running the full SQL join sometimes is not impossible. It's not possible in ClickHouse. And even it is possible. For example, the local lookup or remote lookup is slower because they need to do the real-time join instead of the real-time lookup against the remote MySQL. Again, imagine you have 10 tables join, and the 5 resources are remote MySQL. Five tables are from the MySQL, and some of them are locally in ClickHouse. And the problem is basically if they like to do a remote complex join in the MySQL, it will take like half a second sometimes, or even longer sometimes. And the local lookup, since that ClickHouse does not have multiple stream like Timeplus, local lookup in replacing merge tree, it is slower, and lots of times it's basically not quite efficient because the read amplification is too big.
We have another last question here. How about, the difference between using a dictionary versus doing a direct join against a mutable stream? I think you've touched upon it in this the last question. Which is better? The question is, which is better? Should we choose the dictionary join or a direct join with a mutable stream?
Yeah, that's a really good one. So yeah, we have touched this a little bit in the previous slides. So mutable stream basically have a a different property which support secondary key join. So dictionary, as you know, dictionary always primary key. You need to specify a primary key, and you need to join against the primary key. But sometimes users do not always join on primary key. They need to join on the secondary key, and they need to do, instead of do the one-to-one join, they need to do one-to-many join sometimes. And mutable streaming could be the only solution for the fast lookup. So imagine mutable streaming user can build primary indexes and also secondary indexes for the join. So and also it is also sometimes possible there will be a prefix join. So for example, you have a primary key, and the primary key is a combo key, several columns. But when you do the join, you do not join the full primary key. You join a prefix of the primary key, and in that case, dictionary is not working so well because there will be many one-to-many join. But in mutable streaming, we can support that really easily. So prefix of the primary key scanning, and as well as the prefix of the secondary index scanning will be fast.
We've just had yet another question come in. The question is about the performance comparison between bridged Python UDF and native Python, like the way Timeplus.
Oh yeah, that's a really good one. So in our testing, so for example, when we do the aggregation one, we can in the bridge one, we invoke a sub process, invoke a sub process in of the Python interpreter in the separate process, and also we have a native solution. So the performance difference right now will be 4x. This is for the simple one. If the the aggregation or the processing is very stateful, it will be even bigger because of the back and forth serialization deserialization between different process. For the bridge one will be huge. The overhead will be huge. In the native one, we basically do the in-memory translation. For example, I have the Timeplus data format in memory, and also we have the Python representation. We convert that in memory locally. So that part plays a very significant part when do the data processing.
Thank you, Ken, and thanks everybody for joining. Please check us out on GitHub and join our Slack channel. Until next time in March, thank you very much.
Thank you.